Hello everyone and welcome. My name is Patrick Zobel. Today I will give you a brief overview of our innovation high dynamic turning with FreeTurn tools and how Siemens NX is supporting this new technology to make it applicable for the user. But before we deep dive into this revolutionary technology, let's have a quick look on CERATIZIT. CERATIZIT is a global player in the world of powder metallurgy. We employ 8,000 people working in 30 production sites all over the world. We offer more than 100,000 different products in cutting tools and wear parts. Very important, from my point of view, is the innovative orientation, with 200 people in R&D and more than 1,000 active patents. FreeTurn tools are the best proof of our innovation power. At CERATIZIT, we master the whole production process. As part of the Plancy Group, we have exclusive raw material sourcing. This means that we master the entire process chain. We take the stone from the mine to the production to produce the powder. We shape it, we sinter and grind it, coat it, and after use, we recycle the carbide to close the loop. With this, we ensure our customers the highest quality. With our 4 product brands, we have basically everything for machining. Under the CERATIZIT product brand, we have tooling with indexable inserts for turning, milling, and grooving, as well as ultra-hard cutting material. And we have tool scope. Then we have the Comet brand with indexable drilling, reaming, fine bore tools, as well as actuating tools, with an additional access on the tool directly. The product brand WNT with solid carbide drills, end mills, taps, more or less everything to round up the portfolio, including tool and workpiece clamping. And then we have Clank. Clank is an expert and focused on specific solutions for aerospace industry. With all these product brands, we offer a full range, starting with high quality tooling, process monitoring to get the most out of every tool, and finally recycling to make again high quality tooling. So that's it for a brief introduction to our company. And now let's step into high dynamic turning with FreeTurn tools. The driving force to develop this revolutionary process was pretty simple. Turning, in its most basic form, hasn't changed in decades. What you see here on the left side, the green machine, is a conventional turning lathe. The process is pretty static. You can only change cutting speed, feed, and cutting depth. If you need a different approach angle, a different direction of cut, or any additional adaptation, you always have to change the tool. For that reason, the catalogs for turning tools are pretty thick, and you have thousands of options to choose from. On the right-hand side, you can see a modern multitask machine with a milling spindle inside for additional machining operations. But the turning process is still the same. With FreeTurn, we change this. We use the milling spindle of the multi-purpose machine to achieve incredible flexibility. FreeTurn moves turning from 2D to 3D. We use the Y and the Z axis plus the milling spindle to create the high dynamic turning process. In this video, I will show you how it works. The tool, in this case with HSKT connection, is clamped in the milling spindle. The center of the insert and the rotation axis of the spindle are in line. This offers an enormous increase in flexibility while turning. You're completely free to change the approach angle, even during the cut. With the ability to change the orientation of the tool, we are free to use the tool either left-hand or right-handed, or in overhead position, all with the same tool. Another thing is With the FreeTurn tool, you have the possibility to have the smallest tool change system in the world. Here we have an insert, and this insert is available, where we have two cutting edges with a roughing chip geometry, and we have one tip for the finishing application. Combined in one insert, you can switch fast and nearby the work part from one edge to the next. How does this look like in an example? This is shown here. It's machining of a steel shaft on a state-of-the-art multitask machine. We start with machining a 90-degree shoulder. By the way, we look in this moment from underneath to the top of the machine. The camera is lying on the floor in the machine, so we can view the process. This orientation of the machine gives us a very nice chip evacuation. Good. The shoulder machining is followed by opening a pocket. You see now the FreeTurn tool is moving backwards and forwards. With this, we reduce the non-cutting times to an absolute minimum. No empty tool paths. In addition, we use the left and right hand cutting edge of the tip, which results in a better tool life as machining only in one direction. And now finally, the finishing. The cutting edge is following the contour perfectly. Good. Now I guess you have a good idea what high dynamic turning with FreeTurn tools is. When talking about this innovation with all the possible benefits, immediately the question comes up how to program the motion of the tool. This is the point where NX comes into play. CERATIZIT as a company has a long relationship with Siemens and NX. We use the software in different departments, in R&D, design, and of course in production. Our experienced people noticed soon that NX manufacturing is well supporting FreeTurn, meanwhile for years. And now I would like to show you some of the features in NX we use for FreeTurn. So what we have here now is the digital twin of one of our machines. This is BMG Mori CTX Beta 1250 TC4A. We have this machine in one of our technical centers. But at the moment, we don't need it. We need a workpiece and chuck to show you the high dynamic turning with FreeTurn. Good. First of all, what NX offers to work with FreeTurn is we can use all the standard operations. So if we create a new operations in turning, we can use the facing, the rough turn OD, the finishing pass, and in NX1953, in addition, we can use the rough turn smooth, which is a really nice option also with FreeTurn. How does it looks like to show you a tool pass? Can show you facing operation. So if you go inside the facing, it is very much the same as you know from working with standard tooling. So we have here tool paths. We can use in NX with FreeTurn all the strategies what NX is offering. We can use the linear SIG, zigzag, ramping, contour SIG, whatever we need, whatever we think it is beneficial for the cutting process. We can change the orientation of the tool for every operation we have. So in the tool settings, tool holder angle, we can change completely free how we want to use the tool. And create a new toolpath, and yeah, the toolpath is adapted to the new orientation of the tool. What else can I show you on the rough turn OD? I can show you some more options we can use. So again, in all operations, I'm able to change the tool holder angle, so I can adjust the tool perfectly well to my process as I want to have it, as I need it. In this case, I can use I have the different strategies. In this case, we have the linear zig. I can change it to a linear zigzag to avoid long cutting moves to a minimum. I have the option to use the smoothing. In this case, you see in the corner, we have sharp corners. If I add the B-tangent smoothing and some radius, I create the tool path. I have a very nice radius to make a soft entrance into the workpiece. And the tool is cutting into the material. And a very, very nice feature NX offers is the automatic feed rate computation. So in comparison to program a feed per revolution as a fixed value, with the automatic feed rate computation, we're programming a chip thickness. What means NX is calculating in relation to the approach angle of the cutting edge to the work part, what feed per revolution the machine must go to achieve this chip thickness. And I can show you an example. If I create a toolpath and go to the simulation, okay, a little bit slower. And let's take the assembly. In the simulation, on the bottom line, you see the real feed, what is the outcome of what the machine will go, and it's not the 0.25. In this case, it's the 0.41. So this is the required feed to achieve this average chip thickness. And on the forward cut, it is 0.26. Again, this is the required feed to achieve this chip thickness. Good, I think we can stop here. What else is NX offering? We can do this operation, of course, on the main and the sub spindle. So if we use FreeTurn, we speak about multitask machines. And so these multitask machines typically have a main and a sub spindle. So we can do the same roughing and finishing job on the sub spindle. If I go in this operation, create the toolpath, do the simulation, again with the assembly and the 2D material removal. So we have the roughing job on the sub spindle. So NX is very well supporting this multitask machine technology. In the beginning, I quickly spoke about this option for smoothing. So this is a new feature, and it's very nice and very helpful. So I can show you to rough machine pocket with using this smooth operation. So if I go in machining, you see in the toolpath there are big radius for entrance, big radius for go back into the material. So we have on the one hand a continuous cut, and then we have a soft entrance in the component, what is really, really nice for the cutting edge. So you see very nice movements back and forward with soft entrance into the component. Yeah, a really nice option to make this pocketing operation. Yes. One more nice feature, especially if we have less space, if we go on the finishing operation. For the finishing operation, we can define the tool path with lots of different interpolation vectors, they are called. So I can define on various positions of the component different positions, and this gives me finally the dynamic motion, the nice motion with the FreeTurn tool. And if we have a situation where we have not too much space to avoid any collision with the work part contour, so we have a good feedback in NX. So NX gives us an optical feedback if we have a collision with the work part or not, if we are safe. So this is really nice. Also, we're working with the 3D, so we see very well if we have any interference contour or if we're safe on this position. Yes. Good. And finally, we can also here do the simulation to see the nice dynamic motion of the FreeTurn tool. Good. For the user, for the programmer in the daily work, FreeTurn is almost the same as the programmer standard tool. So what you see here on the left side is the different operations. They are one in a row with other operations. So if we have here some turning, outside turning operations with FreeTurn, then we have a spot drill operation in of some holes on the front side of the part. So if we have a look on the simulation, it shows that the FreeTurn operation itself is one operation in a row with drilling and milling operations on the main and on subspindle. So for the user, for the programmer, it's very much the same if he works with conventional tooling or with FreeTurn in NX. And this is, my point of view, very nice. Good. So these are some of the features I wanted to show you related to FreeTurn in NX. If you are interested in more details, we are going to prepare a webinar with all the details how to program FreeTurn in NX, about tool definition, path creation, and combined with real machining. So if you're interested, appointments will follow. Yeah. Then I say thank you from my side and have a great day.